Hey everyone, today we are going to start talking about writing algebraic expressions so that we can move into evaluating. So we're heading truly into an algebraic section of our curriculum. An algebraic expression is a mathematical phrase that contains numbers, variables, and at least one operation. That operation can be multiplication or division, it can be addition or subtraction. So I've got a algebraic expression in these big boxes here. So this is an algebraic expression, 3x plus 4. So now we're going to introduce that idea of variables into our lives. So this section right here is going to be a little bit of vocabulary. So you can see these little thought bubbles down here. We're going to talk about some vocabulary that goes in those thought bubbles that align with what each of these pieces are. The 3 is called a coefficient. Okay. And the coefficient is a number multiplied by a variable. Okay, so the coefficient is the number that is directly next to the variable. You are not going to see a multiplication sign in between the number and the variable. You are going to see them written directly next to each other, and you need to understand that it's multiplication. The x here is the variable, and a variable is a letter that represents a number. Okay, so the variable is going to be next to the coefficient. It's going to be directly next to it. We're going to understand that that's multiplication, and that x represents a number that we don't currently know. A plus sign is obviously an operation. We are going to be focusing on plus and minus in this situation. So our terms with our variables, we're going to talk about that next. The pieces that have the variables are going to be one thing, and then there's going to be a plus or a minus sign, and then there's going to be more stuff either added or subtracted from it. And then this last one is called the constant. So the constant is a value that does not change. Okay. And that means that whatever happens to this part with the variable, you're going to add 4 every single time. So that plus 4 piece is not changing. So there's a little bit more vocabulary here. So the next part that we're going to talk about is the terms. The terms of the expression, and I kind of mentioned it a little bit a few seconds ago, was the parts that are separated by addition or subtraction. So this plus sign right here separates 3x from 4, and those are two separate terms. Like terms are terms that have the same variables. So 3x and 4 would not be considered like terms because the 4 doesn't have an x and the 3x does. And then constants are also like terms. That's really important to remember as we get into what like terms are and how to combine them. Okay, so this is an algebraic expression, 3x plus 4. It's called an algebraic expression because it has variables in it. We did numerical expressions with order of operations. Those were just numbers. Now we're throwing that variable piece in there. In this little box right here, you can see I talked about variables and multiplication. So seeing that 5x directly next to each other is going to be 5 times x. You can still see it with the dot in the middle, but you're not going to. You can think of it that way, but when we write our algebraic expressions, you're not going to see it that way. And then also we can have parentheses around it, which also mean multiplication, and we talked about that one a ton with order of operations. So our first example is going to be applying this vocabulary. So it says, for each algebraic expression, identify the terms, like terms, coefficients, and constants. So I'm going to have terms, like terms, coefficients, and constants. So my terms are each of my things separated by addition or subtraction. So in number 1, 6n is a term, 7n is a term, 4 is a term, and 2n is a term. The coefficients, I'm going to do those first. The coefficients are the numbers in front of the variables. So 6 and 7 and 2. So in this box, I'm going to put a 6, a 7, and a 2. Those numbers are all in front of variables. My constant is 4. And my like terms are all the terms that have the same variable. So 6n, 7n, and 2n. They all have the same variable, and I don't have any constants that I can put in that box as well. So number 2, 3x plus 2 plus 10 plus 4x. Those are my terms, My coefficients are going to be the numbers in front of the variables, 3 and 4. My constants are 2 and 10. And then for my like terms, I've got 2 sets of like terms. So I've got the variables that are the same, and I've got the numbers that are the same. So 3x and 4x are like terms, and then 2 and 10 are also like terms. So these are separate from each other in the like terms category. Now for number 3, 3a is a term, and then remember that minus is like plus negative. So negative 6a is my next term, then 8, then 3a. So I can have negatives in my terms. My coefficients are going to be 3, negative 6, and 3. My constant is 8, and then all of those terms with an a on it are my like terms. So 3a, negative 6a, and then 3a again. Okay? So this is just identifying the parts of an expression. Can you identify things that go together? Can you identify what is in front of the variable? Can you identify constants? Okay? So now we're going to head into writing algebraic expressions. So we've got some keywords for operations that we're going to talk about. So our 4 operations are add, subtract, multiply, and divide. We are going to have times where there is going to be addition and multiplication in the same problem, addition and subtraction in the same problem, multiplication and subtraction in the same problem. So we're going to identify different things that mean these 4 operations. To add means to find the sum, to combine, all together. We can say to add. We can say more than. We can say greater than. I'm sure there's more that I'll think of as we go through these or as I look at the examples. For subtraction, we're going to find the difference. We're doing less than, fewer than. Take away. And these 2 are going to be pretty important as we go through writing our algebraic expressions. So less than and fewer than, we have to think of those in a little bit different way. To multiply, we're going to say times. We're going to find the product. I'm going to put the word per in here, even though per usually means division, because we'll talk about how we can use per through multiplication. Of means to multiply, and then I'm going to say multiplied by. To divide, I'm going to find the quotient. I'm going to put per into division as well, because we talk about miles per gallon, things like that. Those are going to be division. Shared equally, or to share would be to multiply, or not to multiply, to divide. Division is obviously going to have the least amount, and you're going to see that the least as well in our algebraic expressions. You're going to see addition, subtraction, and multiplication much more often. So in example 2, and I'm going to try and keep this little box on here as much as I possibly can, it says for each situation, define a variable. This is super important. So we have to say what the variable means in the situation, and then write an algebraic expression. So write the phrase as an algebraic expression. So this says $10 more than Anthony earned. So I'm going to use X to represent my variable. I like to use the letter X just for everything. You can use variables that represent whatever the situation is talking about. So if you want to use A for Anthony, if you want to use M for money, it's up to you. But I like to be consistent and I like to use X each time. So this says $10 more than Anthony earned. And the first thing I'm going to do is I'm going to say, okay, what do I not know about this situation? Well, I don't know how much Anthony earned. So my X is going to represent how much Anthony earned. I should capitalize his first name. So I've got my variable defined, and now I'm going to say, okay, what operation am I doing in this situation? Well, it says $10 more than Anthony earned. Well, I wrote more than in the addition box. So I'm going to say $10 more than Anthony earned. Or I can say X plus 10 as well, because the order of addition does not matter. If I put Anthony first and then add $10, or if I have $10 and then I add Anthony's money, it's going to be the same answer. For number 2, the first thing I'm going to do is I'm going to define my variable. So X equals, and the thing that I don't know, so $12 less than the original price. The thing that I don't know is the original price. So X is going to be the original price. Now this one, I'm going to use less than here. So it says $12 less than the original price. For subtraction, order does matter. So if I am $12 less than the original price, I need to take the original price and take away $12. This is one where I can only write the expression as they have told me. So this means take the original price and take away $12. Number 3 says 4 1/2 times the number of gallons. So X is going to be the number of gallons. And this says 4 1/2 times the number of gallons. So I know that I'm doing multiplication. So I'm going to do 4.5. I like decimals better. It doesn't matter if you use decimals or fractions. And then I'm going to multiply by X. This is the way that you're most commonly going to see it, as 4.5x. Or you can write 4.5 times x, but that could be a little bit confusing with the dot and the decimal. I would not recommend that. And the way that you're going to see it written in general is 4.5x. And you have to just understand that that number and that variable next to each other mean multiplication. The last one says 6 times more money than Courtney saved. So my X is going to be Courtney's money. And I'm doing multiplication because it says times. So I'm going to say 6x. And another thing to pay attention to with the way that I wrote these two expressions for number 3 and number 4, the number comes first and then the variable. So that coefficient comes first and then your X. When we write our algebraic expressions, we do not want the variable to come first. You're going to write the coefficient or the number that goes next to the variable first, and then you can go ahead and write your variable. Example 3 says writing 2-step algebraic expressions. So now we're going to have a combination of things, multiplication and addition, multiplication and subtraction, things like that. So number 1 says 5 less than 3 times the number of points. So the first thing I'm going to do is I'm going to identify my variable. So my variable here is going to be the number of points. Then I'm going to identify the operations that are happening in this problem. So this says 5 less than 3 times the number of points. Now I talked about less than up here. $12 less than the original price meant take away $12 from that original price. This less than works the exact same way. 5 less than 3 times the number of points means that 3 times the number of points comes first, and I'm going to take away 5. the order of subtraction matters. Okay, the order of subtraction matters. So when it says 5 less than, that means you need to take away 5 from whatever's happening. It's almost like a turnaround word. Number 2 says 2 less than 1/3 of the points that the Panthers scored. So my variable is going to be the number of points the Panthers scored. And then I again have 2 less than 1/3 of. So there's my 2 operations. So I've got subtraction and I've got multiplication. So 1/3 times x. Okay, 1/3 of the points. So 1/3 x. And then I'm going to take 2 points away from that. So 1/3 x minus 2. Less than and fewer than are probably the trickiest ones because you do have to kind of think of the operations in the opposite order. The order of subtraction matters. Number 4, we're writing algebraic expressions. So this says a rectangle has a length that is twice its width. Define a variable to represent the unknown quantity, and then write an expression to represent the perimeter of the rectangle. So what I'm going to do on this one is I'm actually going to draw a picture of my rectangle. And when we think about perimeter, when we think about rectangles, we think about length and width. So I'm going to use L. That's not what I wanted to do. I'm going to have X represent the width of the rectangle. Okay, so X is going to represent the width of my rectangle because the length of the rectangle is equal to 2 times the width of the rectangle. So my width needs to be my singular X, and then my length needs to be 2 times that. So the length of my rectangle is 2x, the width of my rectangle is x, and I'm going to follow that all the way around. And it says, then write an expression to represent the perimeter of the rectangle. So we have to know how to find the perimeter of a rectangle. To find the perimeter, I'm going to add up all 4 sides. So it's going to be x plus 2x plus 2x plus x. You can have those in any order because addition does not matter. You can also say 2 times x plus 2 times 2x. Whichever works better for you. Most of us are going to pick this top one where we add the 4 sides together. Number 2 says a rectangle has a length that is 3 more than twice the width. Define a variable to represent the unknown quantity. So the unknown quantity is going to be my width again. So I'm going to say x is the width. And it says the length is. So my length is 3 more than twice the width. Now twice is another one that means multiplication, and then I've got this more than that represents addition. So twice the width is going to be 2 times x, and then more than means to add 3. Now you can add in any order that you want. So 3 plus 2x would also be fine. So I've got this width that is x, and I've got 2x plus 3, 2x plus 3. So I'm going to have x plus 2x plus 3 plus 2x plus 3. I'm adding all 4 sides together because I'm looking for the perimeter of the rectangle. The order that you add things in does not matter as long as you have all 4 sides. We could also write it in this multiplication way. So 2 times x plus 2 times 2x plus 3, but many of us are not going to pick that option. We're going to choose the one where we're adding all of the sides together. Okay, so this is this is algebraic expressions, so being able to identify parts of expressions and then being able to write expressions from words into those algebraic symbols. I'm going to add that word twice up here really quick because we did use it down there at the very bottom.